Hi everyone. So this is a record video on the introduction and briefly what to do in lab 4. So I will be guiding you guys through exercise 1 and 3, and then you guys will be doing exercise 4 just by yourself. Okay. Through 1 and 3, I will guide you through how to make plots, and then you guys will be answering the additional questions under those exercise sections as well. Okay, so let's get started. So lab 4, data analysis using graphs. So as you guys know, that a picture was 1,000 words. So in physics, this is the same. Whenever you carry out some measurement on data, you would like to know the relationship between the quantities you measure. So say you are measuring X and Y, then you want to plot the data to see what's the relationship between the two more clearly, okay? So that's what you can do a lot of times. What you need to have is the computer with Microsoft installed, okay? So you should have it installed now, but if you just in case you didn't get a chance, take a few minutes to install it now, okay? So basically you guys should have the license to install it with your school email, okay? And then the password. All right. So today will be practicing how to plot data using Microsoft Excel. Now I know people sometimes would like to do Google Sheet as well. It's pretty similar, okay, with a little slightly different. But once you are mastering the Microsoft Excel to plot, you should be able to figure out how to do that in Google Sheet as well. Okay, so so as I mentioned, a lot of times when you measure two quantities, say X and Y, all right, and then you might come up with a theory that describes the relationship between X and Y. So then it might be easier to tell the relationship if you plot the two data on the same graph, okay? So for example, you can plot a linear equation relationship between X and Y on a graph like this, okay? Or in many times, the relationship between your two quantity might not be linear. It could be like parabola, it could be cubic, it could be square root, it could be inverse square root, and then it could be hyperbola. Okay, so depending on what quantities you are measuring and then the relationship, okay, you could have different relationship expression in equations. Okay, but basically you can convert all this non-linear equations into a linear equation by replacing the independent variable with a new variable that you define in terms of the independent variable. So for example, if you define a new variable called, let's call it t equals to x squared, okay, so then y is equal to a times t. So then it's a linear function, all right? And then you can do the same here. You can do y equals to a times t, where t is equal to q, okay? So let's do this. If you do t equals to, let me do it here somewhere to give you a visual here. So then if you set that, then your y is equal to a times t, right? So then a times t is a linear function. Okay, similarly, you can do for this, all right? I'm going to just delete this. I don't want to mess up with the line menu, but just give you an idea how you can do the coming up with a new variable that is in terms of original independent variable to linearize this equation. Okay, so that's how you might want to do it. All right, and then as I mentioned in class, you guys can read the entirety of this lab manual to get everything you know. It's well written, and I think it's clear, but just in case you are having doubt, let me know, okay? So as we are talking, as you are watching the video here, just keep in mind I will be in the main room, the Zoom meeting. So in case if you have any questions, just pause your video and then ask me to join your room, okay? There's a feature in the if you click on more on the top of the Zoom settings here, there's a feature that you can let your host know you need help. Okay, then I'll be joining you. All right. So so there are 4 in-class exercises, And then after this, there's as usual, there's additional exercise questions you guys to need to answer and then include them in your lab report. Okay, so let's take a look on the in-class exercise 1 here together. So in this one says plotting and analyzing experimental data. So use Microsoft Excel setup and make a plot of Y versus T using the data provided below in data table 1. Okay, so you are given a time and the distance. So a lot of times you can measure time and then you can measure the position of the object, okay, T. So to copy this, you can click on this guy here, move your cursor over here and then click on this. All right, again, you can right click and then say copy. All right, so then go to your Excel spreadsheet and then click on the first cell here and say paste, keep source format, okay. So you probably realize the original data, the numbers are given in 3 sig figs. Now you only, some of them only have like 1 sig fig and then some of them have 2 or 3. So we want to keep consistent our original data here. So you can click on your data or highlight them and then play along with these two. Okay, so make 1 click, that reduces, now that's increase. Okay, so then you have 3 digits display. All right, so the first thing you want to do is plot this data set. So choose the data again, and then go to the top of menu bar here, click on insert, and then goes choose the chart here, under here, take this one, and then there's this small triangle here, shows more options, click on that one. You want to plot your data as scatter, okay? So now you have plot your data. Now you can specify what's your y-axis and your x-axis, okay, by moving your cursor over to this here with a plus sign, click on that one, then choose the second one down here, down the list, okay, axis title. So you can specify this axis title here by double click on it and then highlight the text. You can override on it, okay? So say this is your time t, which is in second, okay? And then this vertical axis, you can actually do backspace to delete the original text. You can say distance y, and that's unit in the unit of meters, okay? So it's always good that you indicate what the units, okay, on the 2 axes. Now on the chart title, you can double click, same thing here, or you can highlight it. And then say this is, you can say y versus t, okay? All right, now if you go back to the lab manual here, it's asking you to take a look on your plot and then to see if your data look linear. So that means if all these dots are following on the line, okay? So hopefully you will agree with me that they are not, because if you take your pen or pencil, you connect the 2 data dots, then you'll see that the rest is not sitting on the pen, okay, on the line on the pen, so then it's not linear. All right. Okay, so then you are going to answer this question here. Do the data look linear? You probably would say no. All right. So now, as I mentioned, if the data or the equation is linear, you can actually come up with a new variable. So then you can plot the data with this new variable and then the original other quantities, and then to make it linear. Okay, so so this data is pre-given to you. It's given to you, but it's actually a measurement of the a free fall problem that you drop your object just under the influence of the gravitational fall. So then the position as a function time t is described with this equation: y equals to 1/2 gt squared. Okay, so then if you come up with a new variable of let me say x equals to t squared. Okay, so then let me just write it over here for now so you can see what I'm talking. So come up with a new variable of x equals to t to the square. Okay, so then your y is equal to 1/2 of g times x, right? So if you replace t squared with x, then this is your y, all right? So this is what you are going to do. All right. So again, I'll delete this. I don't want to mess up with the lab manual here, but just to give you guys an idea how you can linearize this equation. Okay, so make a new quantity called x, and then that is equal to t to the square. So then your y will be equal to 1/2 g times x. Okay, so then that's a linear function. Y is equal to a constant or equals to 1/2 g times x. Okay, so go to your Excel here. We are going to come up with a new quantity here. So let me call this as t square. That's my new quantity. Okay, so that should be in second square as well. All right, so my new quantity is going to be equal to t squared. So that means I'm going to do all these numbers square and then put them down here. Okay, so the first one will be equal to this first one here, and then do square. Okay, so if I square, now you can just click on that one and then put your cursor, move your cursor over the bottom right here, and then just drag down. Okay, so make sure you have all this covered. So you have 5 t's here. You should have 5 t squares here as well. Okay. And similarly here, you can just copy this one down here. Okay, so just copy the distance down here. You don't need to do anything about the y. Okay, keep the original y. So then set this equal to the first one here. All right, and then you can drag it down as what you did for t squared. So then you have this one comes down again. Okay, so in this case now, let's put borders here for just for visual consistency with the original here. Okay, but it's fine that if you don't. So now let's put these two new parameters here, y and t squared. One thing I would like to point out is that when you have the first column here and the second column here, okay, so the first column is always going to be your x-axis or horizontal axis, and then second column here is the vertical or y-axis, okay. But when we say it, we say plot y versus x, okay, so y versus t. So that means second column is your y, the first column is your x, okay. In wording, the y comes first, x comes next, but in the Excel here, you want to put the x first and then y. Okay, so x, y are horizontal and vertical. Okay, so now let's plot this one. We're going to choose this two column of data and then do the same. Click on the top here, insert, and then you're going to insert scatter. Right. So this is your new plot over here. Again, you can specify your axis titles. So this says t to the square, and that's in second square. Okay, and then the vertical axis says distance, still the distance, y, that is in meters. So your new chart title, you can say y versus t square. Okay, all right. Now this time, if you put your pen along the dots here, you'll see all the dots will follow on the same line here. Okay, so then that's linear. So let's go back to your lab manual here. Now do this in the Excel sheet. Okay, say from the table or the equation given earlier, this has the form of a parabola to test theory. Draw a new, define a new independent variable t squared, which is the x or the new quantity, and make a plot of y versus t squared. Do this in Excel. We just did that. Okay. It says find the best fit straight line to data using trend tools in Excel. Select the linear trend regression type. And then add equation. Okay, so this is what we are going to go back to the Excel sheet. Now to add the trend line, you want to click on one of the data points. Okay, so click, and then all the data points will be highlighted. Now, if you go to again here on this plus here, click on that one. It says trend line here. Click on trend line. Then a trend line will display your graph here, connecting all the data points. Okay. Now, go back to the trend line here option here. There's a this triangle show up. That means there's more option you can choose. Click on that one. Let's click on more options. All right. So click on this guy, trend line option. Okay, the third one here. Then you'll see you can pick linear or polynomial or logarithm or whatever, okay? So because we know this is y equals to 1/2 gt squared, right? So then it's y equals to a constant number times t squared. So this is a linear without a y-intercept, okay? So it's having a format of y equals to mx plus b. There's no b here. So you can set the y-intercept to be 0, okay? You can display your equation on the chart. You can display also your R square, okay? So then the equation and then R square are displayed over here, okay? And then for the meaning of R square, you can refer to the lab manual. It basically tells you how well agreement is between your theory and your data, okay? So if you have R square that is close to 1, that means it's, or if it's 1, that means your data and your theory has 100% agreement, okay? Now, usually your R square should be, or most of the time should be greater than 0.98. Okay, so if it's not, then something probably isn't done correctly. Okay, so let's go back to the lab manual here. Now we have did that. Okay, so then display equation and then display R square. Okay, so this tells you the meaning for the R squares. Okay, so now you want to recall your R square and then answer these additional exercises. Okay, and then for you can write down the slope over here to calculate your G sub M. That means G measured, okay? So because we know Y is equal to 1/2 G times X, where X is equal to T squared, okay? So then 1/2 G is your slope, okay? So you want to solve your G measure by knowing the slope, okay? So let's go back over here. So the slope here says 4.9495, okay? So that's equal to my 1/2 G. So set it up that 4.9495 equals to 1/2 times G of measurement, okay? And then solve for G measurement, okay? And then put that number down here, all right? Now, to increase the units, it's going to be meters per second squared, okay? And then also on the slope, you want to include the units as the same meters per second squared, okay? So you guys are going to answer this one. Now you can pause the video for now and then finish all this problem or the questions answer under exercise 1 before you go ahead. Okay, resume your video. Okay. All right. Now we are going to take a look in class exercise 2 here. So here it says it gives you the data table 2, which is a measurement of mass, and then attached to a spring, and then the period T. Okay, so towards the end of the semester, we'll learn that T and the mass has a relationship expressed by this equation. Okay, so if you measure T and then measure M, then you can come up with data set, and then you can plot the data. You can see what it looks like. Okay, but you can see T and then square root and then M, they are not in linear, right, relationship, because it's square root of M. It's not just M. So now you can, again, you can linearize this equation by coming up with a new variable, okay? You can call it X, okay? Again, so this time your X is going to be equal to square root of M, all right? Then by doing that, then you can plot T versus X, which is equal to square root of M, okay? You'll see there should be a linear function, okay? So let's do this name, okay? So let's choose the data here and then copy it, okay? And then go back to the Excel spreadsheet, okay? So in Excel spreadsheet, you can actually have multiple sheets and in a file. So on the first exercise, let's rename this first before we made a new one. Okay, so right click on that, and then there's optional rename. So just say exercise 1. Okay, hit enter. Now you can click on this plus with a circle. They will give you a new sheet. All right, so again, let's rename this and then call this exercise 2. All right, so in exercise 2, you are going to copy or paste the data that you just copied. Now you see there's this pound sign here shows up. If when that happens, that means the space for each cell is not big enough to display all the digits. Okay, so you can double click here, then it'll give you enough space on that. Okay, and then also here too. All right, now again, some of these numbers are not displayed in 3 digits, so we can play around with this guy, and then to make all the numbers in 3 digits. Okay, you'll see this one now has 4 digits, so we don't want that. We just need 3 digits on those one. All right. So as I say, you're going to make a new variable. So let's call this as square root of m. Okay. So that means this under this column, the value should be equal to square root of what's under this one. Okay. So then let's set it up. Typing equals to sqrt stands for square root. That's the command in Excel. Okay. Put a parenthesis here and then choose this guy and then back parenthesis. Okay. So then you just did the square root of this number. Now move your cursor again to the right button here and then scroll down. You did all the square root of these numbers. Okay. Now let's keep 3 digits. So play around with this too. All right. So now your numbers are in 3 digits. Okay. You want to put just the period over here, and then that's t in second. Okay. You can copy this one. You can say you can copy or type in equals to that cell, B2 cell. Okay, there's a couple of ways of doing this. You can type in B2 stands for this cell, or can click on that cell. Okay, hit enter. Scroll down. All right. Again, I would like to put the border here for better visual. Now we can plot this new column of data with the T. Again, highlighting them and then choose insert. Goes to charts here, select scatter. Okay, so you'll see this, all these dots appears like in a line. Okay, so if you put your pen on top of them, you'll see they all line up. Okay, we can do the same here. We can click on the chart here. Let me see, and then click on this one. We can add axis title. So the horizontal axis will be the first column. Let's call it square root of m. Okay. And then if you want to specify the units, that should be square root of the kilo, m mass is in kilometers, so it should be square root of kilometers or kilograms. Okay. The y axis is the period t in seconds. Okay. And then your chart header, you want to say this is t versus square root of m. Okay, maybe like that. Okay, just something like that. Again, you'll be doing adding trend line. So click on that one, trend line, more options. Okay. So similarly for this one, it doesn't have a y-intercept. Okay, you can see t is just equal to the slope times square root of m. Okay, so then you can just click on the options for the trend line there, and then say set in y-intercept as 0, and then display equation, display r values. Okay. All right. So this time, you can write down your R squares. You can put your equation. Let's go back to this. Okay. So you can write down R square. You can put your slope. Okay. Now you are going to calculate for your K here. All right. So because we rewrite the equation, so now the equation becomes y equals to 2 pi, okay. So you probably want to put everything else together except the square root of m, okay. So you want to do this first, divide by square root of k, all right, and then times square root of m, okay. So this is what you have basically. So basically this is your x, all right, and then this is your slope. So set up that 2 pi over square root of k equals to the slope that you got in your Excel, okay, so which is 11.991. So set up that 2 pi over square root of k equals to 11.991, and then solve for k to go here, okay. All right. So this is exercise 2. Now you guys again can pause the video and then finish the calculation of k, okay, and then after you're done that you can resume the video, okay. So the next 2 exercises are going to be about the linear regression analysis. So under this, the paragraphs under this title is about that. Okay, you can read through this chapters on how to do the linear regression analysis. So basically, when you do the trend line will for a linear function, it will kind of connect all the data points you have on a line, but a lot of times you cannot have all the points online because 2 points will determine a line, okay? And then the rest might be just some extent off from the line. So to put a trend line, the Excel does is it actually will draw a line. So then about half of the dots will be on one side of the line and then the other half on the other side. Okay, it's kind of alternating way in that way. Okay, so then that's the best fit. So then if you are looking for the deviations of all the points away from the line, okay, so you are going to do, so the average, okay, it will be close, average of deviation if you want, say one side is positive, one side is negative. So the average will be close to 0, okay? So if you add the average of what the theory predicts and of your measurement, if you add all the differences up, it's going to be close to 0, okay? One way to tell it is if you have a good fit is taking the squares of the differences from your theory between your theory and your measurement, okay? So then put them together, okay? So if you can get the smallest square of the deviation, then that's the best fit, okay? We can talk about this for like one full semester, how to get this done correctly, but because you guys are not required to do that. This should be like higher level statistic class, okay? So then we are going to just briefly say or go through what's done here. So basically you're going to calculate this deviation of your slope and then deviation of your y-intercept, okay? Use those two, and then they are given by these equations, and then the deviation of this, okay? So each measurement minus the average value, okay, which is the line value at that particular location, okay, for the x and y, and then you add those up, okay? But basically, you guys don't need to know all about that, just need to know how you can do the linear regression, okay? So you are given a data table 3 here, measurement of mass, all right, and then the deflection, all right. So we'll copy data table here, okay. So choose the data table and copy, and then go to your Excel here, add another sheet, okay, rename it, say exercise 3. All right, and then paste your data. Keep the original format. All right, your first column data should have 3 digits, okay, and then second column they look fine as original one. Only the first column has been altered. So you want to preserve 3 digits on the first one. All right. So then it says, use Excel, make a plot of y versus m. Okay, so then m is the first column, y is the second column. Find the best fit. Use the trend line again. Okay, and then display equation and coefficient of determinant. Okay, so let's do that. Choose list 2 and then go on insert, scatter. All right. You can add your axis title. So this is the mass m in kg. All right. This is deflection y. Okay. In micrometer, you can just put mu, u as mu. That's fine. So then this is y versus m. Okay. Graph. All right. And then it says add trend line and display equation. So go to the trend line option and then R square. Okay. So that's your equation. That's your R square. Okay. Let me put somewhere down here. Okay. You can scroll it down. You scroll it up. So let's see. So it says now set up the worksheet for error analysis. Call the independent variable x and independent variable y. Set up 2 columns for x and y. So basically, I'm going to guide you through this. Okay, so I'm going to copy this cell and then put this into my Excel spreadsheet. I'm going to leave 2 spaces, 2 columns empty over there. I'm going to paste it over here. All right. Maybe make it a little bit larger. Okay. So let me move the plot further down here so I can show you all the cells here. Okay. Probably drag this a bit over. All right. So these are the values. That means these are the quantities of n minus 2n, where is the number of measurements you have minus 2. All right. And then this is x s squared ny. So they define in the lab manual. Okay, just before the paragraph before exercise 3. So let's take a look here. So it says equals to count x. That means count the x. Oh, actually, not yet. Sorry. So let me undo this for now. I forgot about it tells us to, it asks us to come up with the x column and y column and the x square column first. Okay, so basically x column is equal to the first column here, so A2, take it down there. All right, and then y column is that y column, so equals to B2, take it down there. And then x square is equal to x square, so equals to E2 square. Okay, and then you can drag down, so take that square. All right, so it asks us to make those 3 columns first before we actually paste these 2 columns down. Okay, so I'm going to keep 2 columns empty here and then 2 columns empty here. Okay, so for this guy here, n minus 2, which is count the x column, so you are count is the command in Excel. Okay, count the parenthesis, and then inside the parentheses the argument that what you want to count. So count the number of measurement on this. All right, so then hit enter. I didn't like the minus sign here, so let's do the minus sign again. And then it shows it's 8. Okay, So that means 10 measurements we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. All right. So this one S square and X. Okay. So we have to see what's this one, but it says this should be equal to VARP. So that means variance of parameter X. So again, delete the X and then take the X column here. Okay. That gives you a number. The next one is S square n sub y. So that means take doing the variance of parameter y. Okay, delete y and then highlight y here. Hit enter. Okay, gives you a number there. Now x squared with the bar, that means an average of this. Okay, so average of x squared. So average is the command of taking average and take that. S square ny over s square nx. So then basically you are doing this over that. Okay, so equals to one cell here, which is the y over the other cell, that is the x. Okay, so then you have that. All right, now R is correlation between x and y. Okay, so x axis and y axis. Okay, so delete x and then choose this column of data over here. And then same thing here, delete y and then choose this column of data there and then hit enter. Okay, so that's R. Now R squared should be equal to this guy square. So this one square. Okay, so delete the cell, but pick the cell above it. All right, so then that's R squared. The next one here is 1 minus R squared. So 1 would be 1 minus this guy. Okay, so 1 minus of this. All right, so M is slope. So slope of y first. So this time y first, then x. Okay, and then b is the intercept. Okay, so y first again, and then x. All right, hit enter. Now delta M square. Okay, so delta M is as cell times cell over cell. So let's go back to, because it doesn't seems like making any sense. So delta M square should be equal to, yeah, let's go up to the theory part. Delta M square is equal to 1 over n minus 2 times SNY square divided by SNX square and then times 1 minus R square. Okay, rather complicated. Let's do one by one. 1 over n minus 2. Okay, so that should be equal to 1 over n minus 2. Okay, and let's put times. We can delete the rest. Okay, for right now. So 1 over n minus 2, and then let's check s square ny over x square nx. So times s square ny over divided by s square nx. Okay, and then it says times 1 minus r square. So times that guy. All right, and then hit enter. That will be your delta M square. Now for delta B square, again, it says certain cell multiplied by certain cell and divided by certain cell. So we are not sure about that. Let's delete it here, go back to the manual. Delta B square should be equal to simply X square average times delta M square, okay? So it looks like it's just going to be this guy times this guy, all right? And hit enter, and that would be that. Now, delta M should be square root of this delta M square, right? So square root of, we can delete that cell, but pick this, the appropriate cell there. And then delta B should be equal to square root of delta B square, okay? So delete that and then pick that. All right, enter. So you have done just the linear regression of list plot. So basically what you need to focus on is list 2. Okay, so usually when you plot the data, it gives you M and B already. Okay, but the interest is your interest should be focusing on what would be the error on the M and B, because M and B given by the plot would be just the average value. Now, as we mentioned earlier, any measurement you will report the average value, and then plus and minus is the error, right? So then this is the its error. So plus and minus the error for the slope, and then the error for the intercept, y-intercept. Okay. So once you have that information, and you can do the error propagation as we did in lab 2 to figure out a particular quantities measurement error. Okay. All right. So this is exercise 3. So we did that. You're going to take down your R square, your M, which is slope, your B, which is y-intercept, and your delta M and delta B. Okay. I'll have you guys do exercise 4. All right. So basically, exercise 4 asks you to use the data from exercise 2 up here. All right. And then figure out what will be the uncertainty on the K value of data table 2 after you've done the linear regression. Okay. So basically, you will figure out what's the data M on this guy, on this set of table. And then because M and K has certain relationship, so you can check what we done in lab 2 to see, because you will have error on data on the M first, then how can you propagate that error onto the K? Okay, so figuring out what's data K. All right. So basically, what you need to do is, it's actually quite simple. Okay, so make a new sheet here called exercise 4. All right, what you're going to do is just copy everything here. All right, over in this, and then paste it over, and then replace these 2 columns with the data given in exercise 2. All right. Now you have 10 measurement here. In data table 2, you have less, so you can delete the rest that is zeros, and then also the rest over here that is zeros. Okay, do remember to delete those. Then everything else will be automatically calculated over here. So you'll get your M, your B, and then data M, data B. Okay, so then you will need the data M and M to calculate what's your data K. Okay, so try to do that, and then let me know if you have questions. Okay, again, I'll be online just to be with you guys. Raise your hands if you have questions. Okay, so I will see you in your breakout room in a little bit. All right, see you.